Alright, good morning everybody. Good afternoon, good evening, whenever you're watching the video. This is our first video for 5.4 scientific notation. We're going to talk about just kind of what scientific notation is. So far we have taken a look at exponents, and we use them just by themselves. B to the n is, we got a whole bunch of rules, things like b to the nth power equals b times b times b times dot 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 b, and we multiplied our base n times together. And that was, we used a whole bunch of rules for that, and those are our previous sections, 5.1 through 5.3. But right now, I guess in this section, we're going to use kind of a special application of exponents, and we're going to talk about scientific notation. Scientific notation is a special application of exponents. What scientific notation really lets us do, it's kind of shorthand for either very large or very small numbers. And scientific notation allows us to write those very large or very small numbers in a shorthand, especially without writing a whole bunch of zeros. So here's a couple of examples. On the number of students in my class, I have about, I've got, 4 sections of class. I've got about 25 students in each section, so I've got about 100 students. So I'm going to write 100 in terms of the number it is, all the significant digits that we have. 1, because here's the 1, and I'm going to say that's 1 times 100, and then I'm going to say it's 1 times, 100 is just 10 squared, right? And 1 times 10 squared is right there, and that would be our scientific notation. And also, we could also say that, and again, this is a number that's got just 2 zeros. But if we got a whole bunch of zeros after this, we could write this number with all those zeros in shorthand without all the zeros this way. Another way is if you get a really small number. Well, here's my salary, and by the way, that is my salary, and you can figure out just what that means. Is it in euros? Is it in French francs? Is it pennies? Who knows what it is? But that's my salary. But it's a small number, and here's a decimal point. There's a couple zeros there that if there were a lot more zeros, it'd be a lot more significant. But again, we write the significant digits here, and we say it's this number here is 1.3 divided by 1,000. We could also say that it's 1.3. I'm going to write out kind of the long way. 1.3 divided by 1,000. Well, that's kind of the same thing. Well, I could say that that's 1.3 times 1 over 1,000. And that's also the same thing as 1.3 times 1 over, sorry, make that a 1 over 10 cubed. And that would be 1.3 times 10 to the negative 3. Because remember, 1 over 10 cubed is 10 to the negative third power, or 10 to the negative third power is 1 over 10 cubed. So again, we follow this kind of chain here. We don't have to do this every time, but this is kind of just an example of what we've got. And here's what we get, 1.3 times 10 to the negative third power. So this number here is the shorthand version. That's our scientific notation. So we're writing, again, things with a lot of zeros in shorthand like this, things with a lot of zeros over here that are very small in shorthand like this. So what's our format? The format is, if you're taking a look at this and you're saying, what's my take-home message? What is my definition of the scientific notation? Here it is, take-home message. Write it on your cheat sheet, study guide. It's a positive number expressed in the form A times 10 to the nth power, where A is between 1 and 10, could be equal to 1, but can't be equal to 10. And then N is an integer, where 10 to the nth power, integers, remember, I guess we'll define our integers, or just review our integers. Negative 3, negative 2, negative 1, 0, 1, 2, 3, dot, 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 dot. Those are the integers. So this A would be this number here, the 1.3 or the 1. That would be the A. And that has to be between 1 and 10. And then it's multiplied by 10 to the nth power. And that 10 to the nth power would be right here, 10 squared, or 10 to the minus third power. And that would be the form that we would look at to say that that's in scientific notation. Again, the whole idea is that you can write either very large numbers or very small numbers in this shorthand in the form of a times 10 to the to an integer power. A times 10 to an integer power. And we'll go through some examples of making a number into a scientific notation number and making a scientific notation number into a regular number or standard number. And we'll also multiply and divide them. So that's all we have for today.